Time feels like a straight line, but today we'll bend it on screen. Miss the shape, and you might waste years planning in the wrong direction. We'll prove that time has a shape you can navigate with speed, height, and gravity. No sci-fi needed. You'll see measurable numbers on clocks we split apart and reunite. Stakes, choose wrong, and tiny daily errors snowball into big, costly misses. A clock is any steady ticker. Time dilation means clocks can tick at different rates because of motion or gravity. You and I are the test. We'll start synchronized, split paths, then compare. We get 1 hour total, 2 locations, 1 sync pulse, and no edits. Success is any mismatch larger than 1 nanosecond, 1/1000th of a second, that we can show on screen. Picture spacetime as a rubber grid. Speed tilts your path through the grid, gravity dents the grid. The straight line of time near you can curve when we zoom out. You take a jet for 1 hour, while I stay on the ground. When we reunite, your clock differs from mine by a few nanoseconds. Motion slows it a bit, altitude speeds it up. At cruising altitude, the net is usually slightly faster. I ride an elevator to the rooftop, while you stay street level. Higher means weaker gravity, so my clock runs slightly faster. To get a full nanosecond in 1 hour, you'd need roughly 2.5 kilometers of height. High-speed neurons made in the upper air live longer from our view. More reach the ground than no dilation math predicts. The count only fits if their time stretches in motion. Speed slows your clock, altitude speeds it up. Our straight time now looks like paths of different lengths between the same start and finish. That is the first bend. GPS orbits about 20,000 kilometers up and moves fast. Uncorrected, each satellite clock drifts by 38 microseconds per day, gravity plus 45 microseconds, speed minus 7 microseconds. That would push your phone's position off by hundreds of meters within hours, kilometers in a day. A mile-high city ages a hair faster than sea level. Scale, about 15 nanoseconds per day at that height, which adds up to only a few microseconds per year. Scheduling, billing, and trading systems still budget for drifts like this. At 90% of light speed, your hour could match about 2.3 hours for us outside. Cost, enormous energy. Benefit, more distance per personal hour. Different path, different time carried. You can't message faster than light, so not all future is reachable. The shape of time draws a cone of possible moves. Step outside it and plans fail by physics, not by effort. Tiny mismatches compound into big misses. Tens of microseconds per day becomes about a millisecond in a month, while nanoseconds per day add up to microseconds over a year. Navigation, finance, and networks survive by shaping time on purpose. You don't ride time like a conveyor. You steer a landscape. Climb a floor, fly fast, or stand near MASH, and you pick a slightly different amount of time between the same events. That choice is small daily, huge at scale. Time has a shape, and you can lean it. Notice the clocks you trust: phone, GPS, cardio watch, and imagine paths through that grid. If you could tilt your next hour a little, where would you aim it?